Good afternoon. Welcome to the Container in Enterprise Cloud Strategy. It's so great to see so many of you here. So you all know that container is still very hot right now. And from various analyst reports, CNCF user surveys, and various vendors reports, we know that the developer numbers is increasing. The user adoption number is increasing. The number of KubeCon attendees is tripling compared to last year. So it's a very exciting time for us. But at the same time, I do think that as a community, we should constantly do a temperature check on how our users are using the technologies that we're developing. This is why I proposed this panel. So in this panel, we are going to discuss how containers are being adopted in real-world production environments. We're going to discuss all the pitfalls, best practices, learnings with everyone here. And today, I'm very honored that we have such an elite and diverse panel here. And this group of people, they have extensive experiences in not just container technologies, but also cloud computing technologies. And more importantly, they can represent 3 geographical regions: North America, EMEA, and Asia-Pac. So we can hear all various different perspectives about how their regions use container technologies in production environment. So without further ado, let's just start the panel. And panelists, thank you so much for joining this panel. And my first question to you is, what's your name? Introduce yourself, and also tell us about your company, the role that your company plays in the container ecosystem. So let's start with Brendan.
Hi, I'm Brandon Phillips. I was the CTO and co-founder of CoreOS. We were recently acquired by Red Hat. And my role over the last 5 years or so has been, CoreOS started before Docker had been released and a lot of this containerization stuff took off. And along the way, helped to originate net new technologies that are in the space, like Container Linux and etcd and Flannel. And then building a number of enterprise products, including Container Registry, Quay Enterprise, and then also CoreOS Tectonic, which we worked with companies in primarily North America, but also Europe, to help them get their foot in the door with Kubernetes in both cloud environments and on-prem. And so that's been kind of my journey over the last 5 years.
Hi, my name is Yin Xiong. I'm Chief Architect of Cloud Platforms at Huawei. Mainly responsible for the container-based platform or services for our public cloud or private cloud. Huawei does have a public cloud, mainly the market in China, and we also have public cloud, joint public cloud services with the some of the telecom carrier, like German Telecom and the French Orange, and they joined public cloud services. So my role is basically, we have something similar to we have something called CCE, it's a cloud container engine, similar to the GKE, AWS Kubernetes services. So we have that service, that's something we're responsible for. In terms of the engagement, we have SNCF. In fact, Huawei was one of the founding members of the SNCF. We have been involved in the SNCF since 2015. Right now, we're currently a planting member of the SNCF.
Good afternoon. I'm Brad Topol. I'm an IBM Distinguished Engineer of Open Technology and Developer Advocacy. I lead our upstream team that does upstream contributions to Kubernetes. I'm also personally a Kubernetes contributor. I'm on the Kubernetes Conformance Workgroup, and I'm a Kubernetes doc maintainer. So from an IBM perspective, we are obviously deeply involved and invested in Kubernetes and CNCF. In fact, my boss is the chair of the CNCF. So we have a lot of people working upstream in a variety of areas, in the lower level areas of containers and things like service catalog. Across the board, we have folks contributing. And from an IBM perspective, we've got an on-prem offering based on Kubernetes, IBM Cloud Private. We've got a public cloud offering, IBM Cloud Container Service. And we've also got tools to help you with multi-cloud, the IBM Cloud Automation Manager. So we're, from the product side and from working in the community, obviously a lot of interest from IBM.
Hi, I'm Nils. I'm from Deutsche Telekom. I'm a cloud architect at Open Telecom Cloud. We provide cloud services on several layers. We provide an infrastructure layer that is made of OpenStack and a number of additional components, as well as the layer on top of that, and that is Kubernetes. And we use for that a product just mentioned before called CCE, the Cloud Container Engine, that sits on top and provides a managed Kubernetes service. Yeah.
Okay, hello everyone. My name is Anni Lai. I'm with Huawei. I'm responsible for the operations of all the cloud-related open source projects under Huawei. And I'm currently also sitting on OpenStack board as well as CNCF board. And I'm your moderator today. Okay, so next question. So panelists, would you like to share one of the use cases, container use cases that you or your company has deployed out there in the production environments? And can you share with us the key learning from that use case? Niels, would you like to start?
Yeah, we ourselves usually don't deploy workloads on Kubernetes or on container engines, but our clients obviously do. And well, we see in the past a huge number of POCs, but already also a number of real production work. And we see a lot of startups coming up with their solutions, because when they start their greenfield projects, a microservice infrastructure just perfectly fits to the Kubernetes world. And so, for example, we have a very interesting startup near my hometown Berlin, and they do some microscopic imagery from yeast. So actually, this is very convenient for brewers to find the right temperature and the right yeast type and so on. And they implemented this stuff on top of a Kubernetes cluster. That's really interesting stuff. And we see a lot of activities like that at the moment. So how about you?
Well, thank you. So, we obviously provide for our customers. We have enterprise customers, and we've been working with customers in retail, healthcare, transportation, financial technologies. And I'm going to kind of look at this from two different angles. From the customers that are coming and wanting to run on the public cloud, what they're really looking for is the fact that we're going to manage the service. So they don't want to have to worry about anything except developing their application. Those same customers typically want high availability. We typically have them run in multiple data centers. And then the piece that gets really interesting that we've seen is dealing with the persistent data, the stateful data, the databases. And this is going to be interesting because it also applies to our on-prem. So what we see in those cases is as they're moving to cloud native and moving to container applications, the persistent piece, the databases, those are typically not running in containers yet. And we'll provide a variety of offerings that are outside of the container space for persistence or for databases. And they feel more comfortable with that. When we go to on-prem, same type of situation, a little more focus on performance tuning, but they still have this issue of not feeling comfortable with their persistent part of their applications. And in those situations, there's a wonderful component of the CNCF and of Kubernetes called the service catalog. Anybody heard of service catalog? It's a wonderful, wonderful way to take things that are running in containers and hook them up with legacy services and databases and other services where you're not quite as comfortable yet running them as containers. And so you can pull a lot of things all together using that piece.
Okay, great. Dean?
Just like IBM, the Huawei also has public cloud and the private cloud services on-premise. We have many use cases too. One use case I want to share with you is one of the early adopters of container technology. It's a company called Channel Mobile Entertainment Divisions. They have a platforms called Migu operation, the backend platforms. We're responsible for process all the authorizations, the billings, the ad pushing the ads to the cell phones. For all the games that the people play on the cell phone. So the platform actually processes 25,000 requests per second. So that translates to 120 minutes per hour. Now, one of they manage actually the platform manages 300 virtual machines as on-premise case. In this case, one of the problems they have is the of course resource utilization, where on the average is like 10% 10% CPU usage for the virtual machines that they have, and like 300 VMs. So the other thing is they don't have end-to-end automation process. A lot of it is manual, right? They manually create VMs, of course, using script, but they manually create VMs, not end-to-end. So they start to move the things to the containers. So they migrate the platform to the container platforms. The first thing actually they observed is that for the same node, they can actually with half of the servers they have, they used to run the VMs. So they see immediately the resource utilization double. Well, half of the servers, they run in containers. So with Kubernetes, they can actually move the app instance around those servers, and they actually can deploy very quickly. So that's really kind of important for them. One of the things that when work with this customer is that it's not just the container, right? It's not just the Kubernetes and you install there. It's they want the end-to-end kind of solutions for the container DevOps to CI/CD pipelines to monitoring, right? To running the lifecycle management to monitoring that. So that's since actually this is not just the one customer. Most of the customer has this requirement. It's not just install the Kubernetes and then you are there. No, it's not. It's have the planet as strategy, end-to-end solution. That's what they're looking for.
So at CoreOS, we had worked with a bunch of customers, but I'll spare the customer stories because a small story about an application we were running for CoreOS.com. So we were running this little API. We built a little API to manage customer data, and we had it set up. We had CI/CD around it, et cetera, as deploying automatically. But kind of an interesting lesson learned, this is just very practical lesson learned, is we never hooked up the pod health checking, which actively checks that each individual instance of the application is behaving correctly. And unbeknownst to us, there was a bug in the system. And the beautiful thing about Kubernetes is it makes it really wonderful to run 5 copies of the application. But silently, these applications were just failing behind the scenes. And so without that pod health checking, they weren't actually getting killed and restarted. And so just slowly the service got flakier and flakier and then just stopped working completely. So lesson learned for us just trying to manage our own systems on top of Kubernetes is try to utilize all the health checking. And once you do, this beautiful thing emerges that the system will continually fail and run out of memory or freeze or whatever. And then the pods will just get destroyed and relaunched by Kubernetes, kind of saving you the hassle. At some point, you should fix the bug, but having Kubernetes work around the bug on your behalf so you can keep sleeping, I think is a high value way to invest your time.
Interesting. So I want to ask you, so for a company to enter into a cloud native or container strategy, what's their biggest challenge? Is it people, processes, number of developers who know how to code in cloud native environments, or politics? And then, how do generally companies resolve that issue? Who would like to answer?
Right to me, or?
Sure.
So I was going to look at that question from 2 different ways. From the provider side, what were our challenges? Just real quick, is providing private connectivity to our container applications, and how we address that is a lot of VPN options that we provide in the cloud. Now, from the customer point of view, is really interesting. They've got to make some decisions about how they move, their applications to cloud native. Obviously, the things that are stateful are a little tough, but even for the things that they can't move, we've seen, well, do you move it lift and shift as a big monolithic application, or do you actually take the time to take the application and maybe break it into a few microservices? With the benefit of, if you can break it into a few different microservices, then those teams can typically work independently, have independent development schedules and more flexibility. So it really depends, how much, if they look at all their legacy applications, which ones are really worth that to refactor and try and do the extra work for the microservices, or which ones should they just try and move over, lift and shift as a monolithic application?
Brandon, you were smiling earlier when I asked that question, so it looks like you have an answer.
Yeah, I mean, we worked with a lot of customers, and it essentially is all of the above. So there's people issues, there's process issues, there's getting the buy-in across the company, whether it's the network owner or the storage owner or the data center owner. But I think I'll just give one example where there's a team inside the organization, and they were charged with refactoring an application from a VM-based microservices into containers. And the way that they sold it to the business was really quite simple. So they had this microservices, and then they were running it in VMs on a public cloud. And so every single microservice had its own VM. And the way that they sold the use of containerization in Kubernetes was really easy. They took all those little VMs and those microservices and put them in containers and ran them on Kubernetes, and then was able to show like an 80% cost reduction because they simply were now running one really big VM with all the containers and microservices talking to each other on top of Kubernetes and inside of this one cluster. And so this was actually a really good, compelling way across the business, because the moment that they were able to show, hey, look, this application is costing us way less than the application was before once we moved it to containers, the amount of interest politically inside of the organization kind of exploded to the point that this team originally was in charge of an e-commerce site and a line of business, and then suddenly they're becoming the Kubernetes experts, and the team is getting other lines of business wanting to use their Kubernetes cluster, and they're getting expertise in upgrades and security and the networking. And so I guess it's a cautionary tale that your buy-in for containerization can explode into brand new responsibilities that you may or may not want to have.
Anyone else wants to answer?
Yeah, well, I think we have all to face it that this big paradigm shift of cloud and containers is here to stay. But the main question is how to deal with that. And I think technology is the part that is tough still, but it's manageable. So key is to have the right people. And to have the right people and to have the right experience with these people, it's key to start as early as possible. Don't start with migrating your major key application, but start with the small ones, with the low-hanging fruits. I hate the term, but it's suitable here. So that you can build up some experience how to design these architectures, and then everything else will go on itself, I think.
Okay. Ing, do you want to address this?
Well, I have a few examples that I can share. We experience the challenges that we have with customers. As popular as Kubernetes is today, it's still complicated to some of the customers, if not most. Especially in the storage and the network areas. Almost all the enterprise has their own server infrastructure, storage infrastructure, has the network policy, network design. So getting this container platform to work on top of this storage and network policy is quite challenging. In fact, they have a storage servers where we have few customers. The storage server is old servers, and they don't want to upgrade with a new one, right? And so we have the developable those plugins, the storage plugin, the volume plugins for the storage. And same thing for the network. They have their own network policies. They use the run applications in IVM. They can access the application with, through the IP address. Now they move to the Kubernetes. The container, the pod, the IP address is dynamic. You cannot access to it. So they encounter all those problems we have. The other problems we kind of experience with some customers is, I mentioned earlier, is one thing is not just the container platform. They have to integrate it with the existing release pipelines, like CI/CD pipelines. They have to integrate it with the existing monitoring systems. And if you pick up this, CNCF, the community, the CNCF monitoring tools, that's easy to integrate. CNCF doing a very good job actually integrate those things. But most of the enterprise has their own monitoring alerting systems you have to integrate with. And another one specific kind of a challenge that we have is one of the customers. Some of the customers are standardized in the OS. One of the OS they have, it doesn't support containers, or it just doesn't support good features of the containers. So we have to build our own kind of containers to adapt to that OS.
Okay.
Yeah.
I'm going to do a little commercial here. So you all know that CNCF just published the landscape document. In case you don't know, you have not seen, it's at l.cncf.io. And if you've seen it, you know that the ecosystem of containers is growing explosively. The good news is great. We got this huge momentum. The bad news is it's really confusing. You don't know what's really solid, reliable, what's not. So I would like to ask the panel, according to your experience, in the container stack, which part is most reliable that you think that users can use pretty safely, and which parts that the CNCF developer community should keep enhancing and developing? Who would like to start? Brett?
Sure. So, what we found is the base components of Kubernetes are very, very solid, so that base infrastructure is fine. Monitoring, logging is very solid, lots of options. The piece where we need to see more work would be sort of the security-focused pieces, the authentication, authorization, certificate management, image management. Those are pieces that in an enterprise, I think you'd want to see more work being done.
Okay. Anyone else? Brendan, no, nothing more to add?
Largely agree.
All right. Sure. Nils?
So I think the Pareto principle applies very much to this whole ecosystem. So 80% of users are using 20% of the tools and the applications, and these 20% are usually very stable. And this is a good thing, and this is a sign of a very healthy ecosystem. And I hope that this stays this way also in the future, because this enhances innovation in the whole ecosystem. However, it's important for users to find out which components are reliable and are stable. And for example, standardization and the open source project process is a very important feature in that. So projects that are under the umbrella of the CNCF, for example, are kind of, QA tested. And this is something I'd recommend for everybody to closely monitor which component is really developed under open source principles, so that users don't get in just another round of vendor lock-in or whatever.
No. Okay. Anyone else?
Well, from my experience with the customer that, as Brad mentioned, this core portion of the Kubernetes is quite mature and stable. In terms, for example, the scheduling, image repository management, orchestrations, and we have not heard major complaints or problems from our customers. But the security, the storage, and networking side, we have I'm not saying that's not stable, but just we have many customers ask the questions about the security, the storage. I mentioned that earlier, and the networking. A lot of customers want to integrate with the third-party storage or or the third-party network policies. How to integrate with that? I think the community can focus on more on this, more extensible, right? I know we are doing. CNCF is doing in the right direction. We create a network policy interface, we create a storage interface. I think it's the right direction to go. But with those interface, the standardized interface is easier to add, actually extensible, add third-party support for the Kubernetes platforms.
Okay, good. So, so we all know that the value proposition of container technologies. Number one, it helps us launch the application services a lot faster. Number two is to make the infrastructure resources a lot more efficient. And I think another benefit or value proposition of containers is container interoperability. And so no vendor lock-in. But this is such a broad topic. So I would like to ask the panel to clarify from your customer or from users' perspective, how do they see container interoperability? Where are we, in terms of container interoperability? And does standard play an important role in that? If yes, which part should be standardized? So I know it's a big question, so who would like to address that first? Brett?
Sure.
Okay.
I really like this question. I am on the conformance work group, and in other open source cloud communities, I did work in interoperability. So, fabulous question, by the way. Interoperability is huge. It's huge to our customers, and I'm going to let all my colleagues know my best trick when I go talk to my customers, because we should all use it. And I'd say this, God forbid IBM doesn't make you happy. I'm going to feel terrible, but you can take your stuff and you can go to Huawei, you can go to Red Hat, you can go to Amazon, you can go to whoever's running the Kubernetes, Google, and so you should feel very comfortable that if you're picking this, that's what your opportunities are going to be. And it's also going to enable you what we've seen, multi-cloud. Multi-cloud is huge to our customers. So what's been very fortunate is in Kubernetes, we've been doing a lot of work early on conformance and interoperability. I don't know if you heard from Dan, if you mentioned it this time, but we now have 56 companies that are now certified through our conformance program. We had a great model of starting this early while, if you start interoperability too late, it's like herding cats that have run way far away. It's very hard to pull them in. So we started early in Kubernetes. We got everybody on board. Everybody's been wonderful in the community. And we've got a nice suite of certification tests, and we have more resources coming from the CNCF to actually improve the test suite. So a lot of resources to improve the test suite and focus us all on interoperability. So that's huge. And then standards like OCI, standards like CSI, CNI, the plugin interfaces, all of this we found to be huge to our customers. And I think we're on a really good start with this in this community.
Okay. Brendan, you were going to answer?
Yeah, I would say that the way that we've been driving standards is essentially inside of Kubernetes holding the line. I think this question would be different like 2 years ago because there's all these questions around like what is the container image format and is it Swarm or Kubernetes or whatever. And luckily that's all gone. It's Kubernetes. That's why there's 4,000 people here. And then the other piece is just Kubernetes holding the line against all the storage vendors and the networking vendors and everyone else to ensure that Kubernetes has its opinion and that the network vendors and the storage vendors and everyone else come in line with that. I think one of the lessons learned from OpenStack was don't let the API be extended just willy-nilly all over the place. Hold the line and then show vendors where they can plug in. And then that allows and enables things like the conformance tests and that sort of thing to happen. And I think to the credit of a lot of folks in the Kubernetes community, we've done a pretty good job of that so far. And it's an ongoing discussion. Because obviously you don't want to like completely shut down any innovation that's coming out of the network and storage vendors, but you also don't want to work your way into a corner where applications have to be re-architected every time they move between a Kubernetes. And that's something that I think is an opportunity that we're executing on here, which was an opportunity that was very similar to Linux 15 years ago, was Linux provided an abstraction across all the network and storage vendors when they were competing over hardware, and Kubernetes is providing a abstraction over network and storage vendors when they're all competing over cloud and APIs. So,
Okay. Anyone else?
I think from my opinion, from customer perspective, the portability of the applications is really important to them. In fact, they really want to write the same application, write the same code, they run anywhere, and in the private cloud, public cloud, or anywhere they want it. So, and they manage it by the same tools, and that's one really they want it. In fact, in one of the survey just released a couple months ago, that they ask why you use the Kubernetes or containers in this case, and they actually rank number one, the portability. They want the portable. So if this means that we want the same image format, the same runtime environment, the same storage, the same the network, and that's where we need to standardize, or at least interoperable among those interfaces. So I think the CNCF now has CPI, CRI, CSI, and CAI. Those are great kind of a standard interface that helping this product moving forward.
Mm-hmm. Okay.
So one single item I'd like to get sorted out is, from my personal opinion, the container runtime. So don't get me wrong, I really like the variety we have here and the, really big span of different technologies. I thought I learned about 2 or 3 new runtimes just the last couple of days. But I think, especially for users, it is important to get more documentation and more material that supports them in their decision process, which runtime to use in which cases, or how to architect their overall infrastructure. Because at the moment it's a little bit, confusing at times. That's my personal opinion. But obviously, luckily there have been some very insightful talks here on KubeCon. That is the good point and the good news here.
Great. So we are reaching the top of the hour, but I have to ask this question because I think it's fun. So just to humor me, I like to ask the panelists, it's like, if you can share your crystal ball with all of us, what do you think 5 years from now container technology will be? I'll give you multiple choice, Number one, it's like still the same. Lots of growth, lots of new projects, but still confusing, all right? And then KubeCon is gonna be probably about 10,000 people. Number 2, container technology is so boring because it's done. Everybody's using it, everything's automated, enterprises are using it, nobody's talking about it, but it's there in every data center. Number 3, it's gone. Not because it's done, it's because it got cannibalized by other technologies. Number 4, any other answer you can think of? So who would like to start?
I would say that it's just container technology will be just de facto everywhere that you go. And I think what are the signals that makes me believe this? One is that all the companies I stepped into as CoreOS customers, they were adopting it, whether they're a super small company or a huge company, and it was solving real problems, whether it was removing a bunch of random bash scripts they're using to deploy their code, or helping with the observability of their mission critical systems. And so there's just so many business problems being solved. And then, so you have business problems being solved, and then you have every major enterprise software vendor, whether it's Amazon, Google, Red Hat, Microsoft involved in the technology. So it's a really good culmination of people actually using it to solve problems, and then businesses actually bringing products to bear to help accelerate the problems being solved. I can't imagine that we're going to not be talking about it, and it's not going to be everywhere in 5 years.
So the answer is 1 and 2.
Sure, yeah.
Okay. Who's next? All right.
I think my opinion is the same as Brandon's, that in one of the surveys, I mentioned the surveys that I just done a month ago, they did a survey about 4,000 customers, enterprise customers, and they released the surveys last month. And in that survey, they asked, in that survey actually say that 30% of the customers, enterprise, you already using containers in production, and 30% of in the testing, and another 30% of in evaluation. Right? And if you add this together, it's 90%. It's 90%. So the market, this world is already going in the direction that we're massive use of the containers, because they really provide the benefits, right? Portabilities, all those, packaging faster, deployment upgrade. This really provide the benefits to the business. I think that's my opinions on that.
Great. Brad?
So I think what you'll see in, say, 5 years is, from the enterprise side, that they will have been able to successfully migrate many of the applications that they wanted to migrate to a cloud native, to a container Kubernetes-based infrastructure, and that's going to be, wonderful. And I think you're going to see the Kubernetes platform become more ubiquitous. I think you're going to see what converges on it is deep learning, machine learning, high-performance computing. All of these are going to be building on top of this infrastructure, and it's going to be an exciting 5 years.
Great. Niels?
I pick answer 2, but without the boring. So
Without the
I
boring.
think it will be a commodity to run on a CNCF level. But I also expect clusters sizes to increase dramatically, where we have often smaller deployments with 10 or 20 nodes. Why not have thousands and 10,000s of them and manage them with technology we might not have today? And I think we will see in 5 years also a different approach to security. Most probably fueled by some privacy activities or privacy issues that spark a new feeling towards the security to overcome those problems.
Okay, great. So we have reached
Looking
our
forward.
time limit. I'm sorry we don't have time for audience to ask questions, and I would like to thank you for your attendance, and thank you panelists for your participation. Thank you.
Thanks, Annie.